Hi and welcome to Geeks for Geeks. Today we would be discussing the problem longest possible route in a matrix with hurdles. So, in this problem, we are given a matrix with n rows and m columns and with a few hurdles, and the hurdles are denoted by 0. Okay, so hurdles are 0, or you can say that they are the blocked parts which you can't visit. Okay, blocked, and they are arbitrary placed. That means they can be placed anywhere, and the length of the longest possible route placed from the source to the destination. तो इसका मतलब यही है कि वी आर गिवन अ मैट्रिक्स, एक मैट्रिक्स दिया रहेगा जिसमें n रोज और m कॉलम्स है. ओके, जैसे ये मैट्रिक्स है, इसमें n रोज और m कॉलम्स है. अब दो चार हर्डल्स भी रहेंगे, जैसे 0 0 0. So we would be given few hurdles too, and moving forward we would be given a yx and yd. This is the source and this is the destination. So we are told that we need to start from 0 0. Okay, and then we need to reach to 0 0, then 1 0. Okay, 1 1 1 2 1 3 1 4 1 5 1 6 1 7 1 8. So, so just like in this matrix, we are told that the source is here and the destination is here, that is 1 8. So now we can see that the longest path we can do is this, 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 this. And fast forward, we have already done this. But my way is that we shouldn't travel from here to directly here. We can do this also. Okay, we can do this also. But we can't do this. Or we can do like this also. But this is not the answer desired. Why? Because there exists a path that is longer than these two. So we need to take the longest path. But there is more to it, that we can't revisit the same one again. Like we can't, suppose this is 1, 2, suppose this is 1, 1, 1. So we can't do like this, like we would go from 1, 1, 1, 1, 1, 1. So this would be an infinite. But we neither we can go twice nor we can go more than that. We can only visit one cell at once. So we are told that from a particular position, we can move to the adjacent side. So let us understand what do we mean by adjacent. Suppose this is 1, 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 this is 1. So suppose everything is unlocked as of now, and we are standing at this position. So we can visit either of them. So we are told that we can visit the adjacent ones. So what do we mean by adjacent? Adjacent means that we can go up, we can go at the left side, we can go at the right side, we can go at the down. Now, to go from here to here, we need to think of something. Suppose we have 0 0, then we have 0 1, then we have 0 2. Okay, then we have 1 0, then we have 1 1, then we have 1 2, then we have 2 0, 2 1, and 2 2. Is this fine? This looks simple, but this would drive us to the solution. Why? Because see, from this particular position, I can move up, left, and right. So basically, we know that if we move, if we are at this current position and we want to move at the left hand side or the right hand side, suppose let us go to the right hand side. If we want to go to the right hand side, then if we have a value x and y, then see y plus 1. So for moving to the left hand side, we are doing y plus 1 and x would remain the same. If we are moving on the left hand side, then x remains same and y minus 1. Okay, so this should be. So if we want to move to the right hand side, then we can see that x is same and y is incrementing. That is why we can say that if we want to move on the right hand side, then we need to increment y plus 1. If we want to move to the left hand side, okay, this is left hand side, then x remains the same and y minus 1. In the same way, if we want to go to upward, we can see that x is getting decremented, that is x minus 1. Here x is getting incremented, and other than this, nothing is changing. only either of x or y is changing. If we move diagonally, if we move this side or this side or this side, then the value of x and y both can change. Okay, so we can see that if we are moving at a particular direction, then if we want to move up, down, below, or left and right, we can simply go there by doing y plus 1, y minus 1, x plus 1, and x minus 1. This is what we need to do. Fair enough? So now we should proceed forward. Now to go to a particular direction, suppose I am standing at this particular direction. Now we can go till this point and we can see that how many distance are we covering. We can go like this also, and we need to see how many distance we are covering. We can directly go here also. Suppose this thing is here, and suppose this thing is we are moving here. So we can see that we need to traverse all path and we need to find the longest path. Then we need to return the length of it. हमें हर तरह जाना है, हर तरफ से जाना है, और जो सबसे लॉन्गेस्ट पाथ लेके देगा वही हमारा आंसर होगा. Simple. Now we can see that if we need to explore all possibilities, okay, if we want to see all dimensions, if we want to cover all dimension, then as I told, the first thing that you should think of is using recursion. Okay, if we want to traverse all path, if we see all dimensionality, then we need to use recursion. Fair enough? So now, how would we proceed to recursion? To proceed to recursion, first, what are the steps? The steps are deciding a base case, then deciding the parameters, then deciding the intermediate case, and then deciding the, according to the parameter and all, then deciding the return time. So let us discuss the first thing, that is base. So for the base case, what is base case? Base case is the smallest valid solution that you can solve by yourself. So what is the smallest valid situation that you can solve by yourself? The smallest valid situation that you can solve by yourself is a 1:1 matrix, that the source is equal to destination. If source is equal to destination, then there is no path, okay? And the answer to this is equal to 0, because the length of the path would be 0. So source is equal to destination, then the source would be 0. And this is the base case. Now let us think of the intermediate case also. Suppose we are standing at a particular position, then we can go to left, right, up and down. But there is more to it. This side we have drawn that there is no blockage. But we can only move to the right hand side if there is no blockage. मगर मतलब चारों तरफ जा तो सकते हैं, मगर चारों तरफ जाने के पहले हमें ये भी तो देखना होगा कि वो रास्ता ब्लॉक ना हो. So the intermediate case is all direction and each is valid. That is, each one is a valid path that we are taking. Okay, this is what we need to do. So now let us first discuss the parameters. According to the base case, we need to just compare source is equal to destination or not. If we only need to compare that source is equal to destination or not, then we want the parameters to be x coordinate, that is source x, source y, destination x, and destination y. Yes, and to traverse on the matrix, okay, to traverse on the matrix, we don't need that. We just need to know. So for the intermediate case, we need to know that all the directions which is valid or not. So to get if the direction is valid or not, we need to check with the matrix that वो रास्ता है कि नहीं. So we need the matrix itself also. The matrix is done, base case is done, intermediate case is done. Let's think of the return time. So what do we need to return? So we need to return an integer. That is the longest path. So yes, we can say that the return type would be nothing but simply int. So if you have designed all of this, then the recursion is complete. But there are some few more things that we need to discuss. The few more things that we need to discuss is, suppose we are standing at a particular position like this, and we are currently at this position. Then at this position, moving on the left hand side is allowed, moving on the downside is allowed. So left is allowed, down is allowed, but up and right is not allowed. Up is not allowed, right is not allowed. Why? Because we need to be inside the matrix. So what we need to do is, we need, before going on the left, right, up or down, we need to first check that we have any boundary that is left or not. तो मतलब चारों तरफ जा तो सकते हैं, मगर वो चारों तरफ मोहल्ले के अंदर भी तो होना चाहिए। मोहल्ले के बाहर तो नहीं जाना है ना, मोहल्ले के अंदर ही रहना। So to check that we are inside the dimension or not, what we can do is, if x is less than equal to 0, that is, if it is x is negative or it is greater than equal to the size of the matrix, then it is outside. Just this two, check for x and y both, and it would be done. Now there is one more case that needs to be handled. We are working on the 4 path, but for a single valid path, we can't visit the same thing again. But we are going on for all the path. So what we need to do is, suppose we are visiting, suppose this is 1 1 1 1, and I don't want to visit the same node again. Suppose from this node I am going to this node, I don't want to visit this node again because only one visiting is allowed. What we would be doing is, we would be marking, after we visit we would mark it 1, after we visit mark it 1. Why? Because it would be just marking the territory that yes, I have already visited it, there is no need to visit it again. That is what we would be doing. Okay. And to allow the path for all the other traversals, because first we are going on the right hand side, okay, then we are going on the left hand side. So for right hand side, for single path, we can't revisit the same node again, but we can revisit the same node again for the left path. So after making it 1 for the single path, then to the next iteration we would again make it 0, and this is just knowing as backtrack. ओके, मतलब क्या करेंगे ना, कि एक रास्ता में चल गए, वो रास्ता में फिर से विजिट नहीं करना, मतलब एक ट्रैवर्सल फिर से विजिट नहीं करना। तो एक बार बता दिए कि हाँ हाँ ठीक है ठीक है ठीक है, ये हमारा पाथ नहीं है। सपोज आई वुड जस्ट टीच यू, सपोज वी आर एक्सप्लोरिंग फॉर ऑल डायमेंशन, सपोज दिस इज अ मैन and this is the road that he needs to traverse. So what he did was, he was traversing as this road, and then he first came here, and then he told that yes, I would mark this territory, that I won't come here again. Then he would come here, mark this again. Okay, mark this again. But suppose a next person is coming here. So when a next person is coming here, we need to remove this because this person has not visited these all this. So to do the reverse thing, we are doing backtracking. That is where backtracking idea comes. That is why many people ask me that why backtracking is coming into picture, how we are gaining the intuition that yes, backtracking needs to be done. This is the point, that was the intuition. Yes, backtracking is needed. Now let us move to the implementation, and you would have a better understanding of it. Okay. So we saw that the x and y, that is the destination, is not changing. Only the source is changing. But yes, the source is changing because for the recursion, suppose we are at a particular position, this, and the destination is this. So what we would do is, we would first complete for this, and we would say solve for the rest. So source is changing, but this one would remain as it is. So instead of passing the destination again and again, what we would do is, we would have something known as fx and fy. Okay, final x and final y, and we would just save this here. That is, fx is equals to xd and fy is equal to yd. We would just save this. We won't be saving the matrix because that would be taking big of n again. So we would use the same matrix again. But as this is a variable and this won't affect the space complexity because there is this variable, that is why we can move forward with this. And this won't affect the time complexity also. So now, for the very first place, we would just check if the source is equal to 0 or the destination is equal to 0. Then there is no point in moving forward. Suppose we can't start from the source or we can't reach the destination because it is a blocked point. That is why we would just check that if matrix matrix, okay, we would check that if the matrix of xx and xy is equals to 0, or matrix of final x and final y is equals to 0 or not. Okay, this is just xd and yd. Okay, xx, yx, and xx and xy, and xd and yd. This source and destination. And this would be ys. Then we would just return -1, because we are told that if we can't visit it, we need to return -1. And then we would start the wrapper function. So we would just name it as rec because we are using recursions here. And we would be using int I and int j itself. Okay. Then we would have this matrix passed on by pass by reference because it is faster. And this time I would just name it as m itself. Okay. We don't need to pass the final and the initial final thing. So what are the things we need as parameters? As parameters, we need Sx, Sy matrix itself, and dx and dy is not needed because we have initialized them in the global. We can just ask them from there. So the first comes a base case. We have discussed that the base case would be that source is equal to destination. So we can simply say that if I is equals to fx and j is equals to fy, then we would simply return 0 from this point. Okay. Now what we would do is if we would check that the first point is within the matrix or not. Okay. So if I is less than 0, or I is greater than equal to m dot size. Okay. Greater than equal to, this is just simple that we are inside the matrix value or not. Again, the same thing, j is equals to 0, or j is greater than equal to m of 0, okay, m of 0 dot size itself. We're just gaining the size. And we would return a very negative value here, that is 1e9. Okay, we are returning a very negative value. Then what we would be doing is, if m of I and j is not equal to -1, okay, or is not equal to 1. Yeah. So if it is not equal to 1, that means it is 0. So what we would do is we would return minus of 1e9. Okay. If not equal to 1, that means it is 0. That means it is blocked, and we would return from that point only. Else, we would first make it visited. Okay. That yes, you can't visit it again. This is what we are doing. That for the next iteration, this would be a blocked one. So we can't iterate from here. Then we would go to the right side. So for going towards the right side, what we discuss? Right side, so we discussed that y would be +1. So I and j +1. Okay. So as we are moving just one step to the right, so the path would increase by 1. That is 1 plus rec of I and j +1 and the matrix itself. And then we would copy this again and again, because even if we go to left, right, up and down, it would all count to 1. Left, this would be right, up and down. Okay. So this would be right, and this would be for left. So for the left part, we are going to y minus 1. So this would be nothing but y minus 1. So for going to the upside, or going towards the up hand side, we would be going to x minus 1. X minus 1. Okay. And this would be x plus 1. And this would be just the j itself. And then see, for suppose we are moving to the right hand side, first we are marking it non-visited. Then for this path, it should be again made that yes, now it should be 1. So what we would be doing is After the work of write is done, okay, after this is done, what we will do is m of I and j is again marked as 1 for the further iteration. And then we would return the max of left, right, up, and down. Okay, so this should be D. So LRUD. D is x plus 1. X plus 1. So it would be left, right, right, left, up, and down itself. Okay. This is how what we would do it. Next, we would call this function that end answer is equals to rec, or we would give the source that is xs and sy, xs and ys. Okay. And then what we would do is we would give the matrix also. And then we would go and pass the matrix also. After we have passed the matrix, we would return this as the answer itself. Now let us compile and run and see how many errors are we making. Okay, we are getting corrected for the sample test case. Now let us submit this. And yes, we got an AC. That's it for today. Thank you and have a nice day.